Hi, and welcome to the video on scaling, resizing, interpolations, and cropping. So it's a lot of little things we'll be doing in this chapter, and they're all quite simple, but you need to know this stuff because they're very important in computer vision. So let's take a look at resizing or scaling and what exactly is the difference. Well, they both seek to enlarge or reduce the size of an image, that's self-explanatory. But the difference is that resizing seeks to change either the height or width or both of them, and they don't tend to be at the same scale. So imagine we can resize the square by doubling the width, but keeping the height consistent or constant, and we end up this rectangle. However, in scaling, we seek to keep the height to width ratio the same. So scaling keeps the image dimensions, or the image ratios, I should say, together or constant. So you end up with a square. So no matter what you do, you can scale by, say, let's say we're scaling by percent. Can scale 1000%, 500%, or even 5%, and you still have the same height to width ratio, which is giving us our square. Okay? So now let's take a look at interpolations and how do they relate to resizing or scaling. Well, firstly, interpolation is a method of constructing new data points within the range of discrete or known set of data points. So what exactly does that mean? Okay, so let's imagine we're a car, and this car is traveling along the savannah here. It's Queen's Park Savannah. This is in Trinidad and Tobago. And red are our existing points, and yellow are interpolated points. And what does that mean? It means that, let's say our GPS is logging our coordinates every 30 seconds. So we have a red point here, a red point here, and a red point here, and a red point here. Good. So interpolated points means that we're going to start to automatically generate points between these points, so that we can infer the space between. So that's how interpolation does. It looks at this and this point and gets an average here. Same as these 2 points, gets the average point here. But look what happens here. We're rounding a corner here. This is our actual point. However, the interpolated point is going to put us somewhere in this diagonal triangle here, which is wrong. But it's not actually wrong, it's just how it calculates it. So how does this relate to images? Well, imagine you're resizing an image now. And when resizing, you want to try to infer points between the other points. So it's kind of hard to illustrate this by talking. So what I'm going to do, I'm going to move on to this slide here. So imagine this is our original image here, and we're blowing it up. We want to try to get the enlarged image to be as crisp and clear as possible. Now, this is a bad example of what bad interpolation does. You can see here, it looks very blocky, very jagged, not high quality. Now, in good interpolation, all these points here that make this look so jaggy and blocky are inferred at a much better rate. Now, using standard algorithms, it's almost impossible to get a high quality enlarged image. So all those things you see in CSI and all those TV shows where they take a very, very blurry, blocky image and enlarge it to get super high quality, well, it's not quite possible. However, there are some deep learning methods that are quite good, but it's almost impossible to get a highly accurate detailed image out of a blurred image. Alright, but the best we can do is by using advanced either deep learning or some advanced interpolation algorithms. So now let's go back to the slide, and OpenCV has few interpolation algorithms here that are quite useful, quite good. None are fantastic, but they work quite well, and what they do, they use different methods here to average the points between pixels. So when we enlarge it and we have to add pixels between our pixels, because that's what's happening here, we try to get the closest inferred pixel as possible. So instead of having a point here, we're going to accurately assess the point here. So now I hope you conceptually understand what interpolations actually are and how they relate to computer vision and how we infer points when we enlarge images. Because always remember, if this image has say 100 pixels here and we're blowing this up to 200 pixels, we're adding 100 new pixels to our image. Pixels that are going to be in between these values here, and we want to infer the color and light and luminosity, all those things as accurately as possible so that we don't end up with something like this, which is a bit low quality and blocky. So now let's move on to something a bit simpler, which is image pyramid. So pyramiding images refers to either scaling up, which is enlarging, or downscaling, which is shrinking images. And OpenCV provides a quick little function to do very, very quick resizing or scaling of images using the pyramid function. You'll see it in our code in the practical slide. However, now let's move on to something a bit more important and useful, which is cropping images. Now, cropping images refers to extracting segments of that image. So pretty sure we all do cropping of images using our mobile phone apps or all those photo editors. What if you took this nice, cool picture here, However, there's some goofy person photobombing the image on this end here. We just want to crop him out, and cropping him out means you're actually keeping a section of the image here, drawing the section that you want to keep. And we can do that with code in OpenCV, which you will see shortly. So now what have we learned in this video? We've learned the difference between resizing and scaling, interpolations, image pyramiding, and cropping. So now let's move on to practical part of this exercise, where we'll take a look at scaling, resizing, and playing with some interpolations as well as cropping images, all in OpenCV. Thank you.